Assalamu alaikum class 9 students. Today we start exercise 3.2 and the question number 5 and the question number 6. In last lesson we already discussed about logarithm form and exponential form. Today we have to solve question number 5 and question number 6, in which we have to simplify or we have to evaluate logarithm of 512 to the base 2 times square root of 2. Student, first of all, we have to suppose this logarithm value, that is logarithm of 512 to the base 2 times square root of 2, can be written as in the form of logarithm of base 2 of 2 square root of 512, which is equal to x. Means we have to suppose this logarithm value with a variable unknown, that is x. Now student, we have to convert this logarithm form into exponential form. That's why we have to write in the form of 2 times square root of 2 whole raised to the power of x, which is equal to 512, by converting this logarithm shape into this exponential form. That is already discussed the basic theory and basic concept in last lessons. Now student, this 2 raised to the power 1 and 2 raised to the power square root means 1 by 2. If their bases are same, we have to add their powers, that is 1 plus 1 by 2, and we get final result, that is 2 raised to the power 3 by 2 x, because this 2 has power 1 and this 2 has power 1 by 2, and we have to take bases are same and powers will add to it each other, so 1 plus 1 by 2, which is equal to 3 by 2. Now student, when we prime factorize this 512, we can write it as in the form of 2 raised to the power 9. Now student, if you use the law of equality, if bases are equal, then we write these powers are also equal to each other. That's why we write 3 by 2 x power, which is equal to 9. Now this 2 is dividing. When we shift on right hand side, it can be written as 9 2s are 18 and 3 is multiply, and on right hand side we can divide. So at the end we get final result, that is x is equal to 6. Now student, for your better understanding, we take another part, and that is from belongs to question number 6, that is we have to find the value of x unknown, and we take any part a, that is logarithm of base 2 of x, which is equal to 5. Student, whenever we find the value of x, we have to convert this logarithm form into the exponential form. So we write it as in the form of logarithm of 2 of x, which is 5, is equal to 2 raised to the power 5, which is equal to x, or we can write it as x is equal to 2 raised to the power 5, and at 10 student we get x is equal to 32, and this is the unknown value of x. Now student, you have to solve this question number 5 and 6, and last in using the last lecture question number 4, using this concept converting all logarithm values into the exponential forms and find their values of unknowns. Now student, we start our next topic about the laws of logarithm in for example for exercise 3.3. Student, in this section we shall prove and discuss the laws of logarithm, and then we also discuss how to apply them to find the products, quotients, powers and roots of the numbers. Student, these are the four basic laws of logarithm that we discuss in this section, in which we see that first one, their simple form is logarithm of mn. Mn means these two terms are multiplied with each other. By using the laws of or definition of logarithm, we can write it as in the form of logarithm of m plus logarithm of n, and we prove this statement. How can we write this product shape into the form of sum? And this is the logarithm shape, that is logarithm of m into m. Product shape will be converted into the form of logarithm of m plus logarithm of n when we convert into the separate logarithm form. Next logarithm form is, that is logarithm of m over n, that is in the form of dvm or quotient form. When we convert this logarithm of n or shift this logarithm m and n, we can write it as in the form of logarithm of m minus logarithm of n. The third law is logarithm of m raised to the power m, that is power law. In this case, student, you see that this power n is shift exactly beside, and we have to write before logarithm shape, and can be written as in the form of n logarithm of m. So these are the three basic formulas. We can use this left hand side to convert on right, means if these left hand sides are given, we have to write in the form of sum, difference, and we have to shift their power exactly beside the logarithm. But if we have the shape on right hand side, means we have to shape in the form of sum, we can convert in single logarithm by writing logarithm of mn. If we have different shape, we have to convert in the form of fraction, or either if we shape has it by n logarithm, means for example we have 2 logarithm of x, we can write it as logarithm of x square, means we can further shift this n towards the power m and write it as in the form of logarithm of mn. These are the reverse logarithm laws. Now student, the last law that is known as change of base formula. It can be written as logarithm of base a of n. It can be written as in the form of logarithm of base b of n, which is divided by logarithm of base b of a. Student, in this case we have to write logarithm of n separate and logarithm with base there separate, but this base b and b, this is mathematically is known as common base. Usually we note it as and read as a common logarithm, that is already discussed in logarithm definitions, that is the common base log base 10. For student, for your understanding, note that we usually take logarithm of x to means that we take logarithm of base 10 of x, and mathematically we use two defined values. That is first one in this chapter, that is if you know that logarithm of base 10 always equal to 1. That's why we write this logarithm in some values logarithm base 10 which is equal to 1 to simplify their values of logarithm. And also we have another defined law, that is logarithm of a base of a which is equal to 1. In this case student, we discussed that if logarithm of a with a of a which is equal to 1 means if a logarithm which has base and their logarithm value is same or common, that is verified and proof statement or defined law, that is always equal to mathematically 1. Now student, first of all we use the concept of these logarithm laws in different type of questions. For example, if we take a question of exercise 3.3 in which question number 1 is write into sum or difference form, you see that on left hand side of question number 1, their first part, you see that logarithm of a is multiply with b, in which you see that if logarithm of a is multiply with b, we can write it as and use the logarithm number 1, it can be written as in separate logarithm of logarithm of a plus logarithm of b. In second statement, you see that logarithm of 22 raised to the power 1 by 3, which is divided by 5 raised to the power 3. In this case student, first we apply the law of logarithm, second law of logarithm, that is quotient form converted into subtraction form, that is logarithm of 22 raised to the 1 by 3 minus logarithm of 5 raised to the power 3. But further we can simplify by using another law, that is power law. We have to shift this power 1 by 3 exactly behind this logarithm and write the statement in the form of 1 by 3 logarithm of 22 minus 3 logarithm of 5. Now student, question number 2, solve it by yourself by using these laws of logarithm. But in question number 3, the statement is write the different forms into the single logarithm. Means in this question we have statement, for example we take a part a, that is logarithm of 21 plus logarithm of 5, and you see that this logarithm is exactly in the addition form. So by using the first law of reverse way, we can write it as these two laws in single logarithm by using the laws of logarithm and write these two numbers in the form of product because they are in the form of sum. So we write their shape in reverse form using law number 1, that is logarithm of 21 multiplied by 5. So student, in this way you use this concept and simplify and complete and solve all their remaining parts by using the laws of logarithm from question number 1 to question number 3. Thank you. Allah Hafiz.